Hey everyone, this is George. Today's math video is about transformations of functions, and specifically transformations of quadratic functions. Those are the ones that look like that, like parabolas. But before we talk about transformations and quadratic functions, it's worth backing up a little bit and just talking about different families of functions in general. So linear functions, quadratic functions, cubic functions, etc. A fun little picture that I found. This is a nerdy Instagram account that I follow that posted this. You have these little characters that are doing little arm dances that show, that represent different graphs of these functions. So y equals x, for example, is a linear function. It's just a straight line. Y equals x squared is a parabola. Y equals x cubed is this squiggly line. You also have the inverses of those. So y equals negative x is a downward facing line. Here, these are the trigonometric functions: sine, cosine, tangent. They're a wave. A rational function with these lines right here and the horizontal and vertical asymptotes. And exponential. That's the equation of a circle: x squared plus y squared equals r squared. That's kind of fun. Someday maybe we'll make a little TikTok competition to see who makes the best video with these little arm dances. But in the meantime, I'm going to show you on the graphing calculator what these functions look like and how you can transform them to look differently. So that's a linear function, so just a straight line. Quadratic function, parabola. Cubic function. Trigonometric or periodic function, which is a wave. Rational function, 1 over x. So x can never be 0, so you have these vertical and horizontal and vertical asymptotes where these lines never quite touch 0. Absolute value, which looks like a V. That's a circle. There's a few that I didn't even put in here, but probably the one that's most in the news these days is exponential, where y equals a to the x power, right? So when a is 1, it's just a straight line. But when a starts to increase, then you have this sharp increase, exponential increase. So the coronavirus, for example, looks something like this, right? Where if each person infects 2 other people, then you have this skyrocketing graph. That's kind of the idea behind social distancing, is to try to get that number to be as low as possible so you can flatten the curve, quote unquote, flatten the curve. And then enough people end up building immunity that this eventually comes down. But that's not the topic of today. So I'm going to close that. We're talking about transformations of quadratic functions, but let's look at a linear function, because your whole math life you've been told that the equation of a line is y equals mx plus b, right? And you can change the values of m, you can change the values of b, but if you just make the values of m 1 and the value of b 0, then m times x, so 1 times x is just x, and then b is 0, so that just crosses out. So then you just have y equals x, right? This is just y equals x. But if you change the value of m, if you make m higher number, then it becomes steeper. If you make the m a negative number, it becomes a negative slope and starts going down, right? So that's if you change the coefficient, right? The number that's in front, m. If you change b, whatever you're adding to the end, that just moves the graph up or down. And you can do this with all different functions. So I'll show you with a quadratic function. See, let's say do x squared plus k. We're out a slider for k, right? If you change k, if you make the number that you're adding positive at the end, it's just going to move the quadratic function up, and it's going to move it down. But it's a little more complicated than that. The parent function, or the function of a quadratic equation, so the equation for a quadratic function, is a times x minus h in parentheses squared plus k. And we're going to add sliders to all of those. So if you change k, as we already talked about, it moves it up or down. So I'm going to leave that at 0 for now. We already know that. If you change h, it moves it side to side. So if you change h, whatever is inside the parentheses, it's going to move it side to side. But careful here, because there's a little bit of a trap with that one. It's a little counterintuitive. I'll explain that later. If you change a, it's going to change how dilated the parabola is, or how steep those sides are. So if it's a number between 0 and 1, it's going to look a little more like a half pipe. Once you start going to bigger numbers, it's going to get steeper and steeper. Those walls are going to get steeper and steeper. Negative number is just going to flip it to the other side of the x-axis. So it's like a mirror image across the x-axis. Okay? So, that being said, let's go to IXL now. Find g of x, where g of x is the translation 2 units down of f of x equals x squared. So x squared is the same as 1x squared, right? So that number a is just going to be the same as 1. We're going to keep that the same because there's no change in slope. We're not flipping anything around. 1 times x minus, and is there any side-to-side motion? No. It's only saying 2 units down. So I'm going to keep that at 0. I'm going to keep h at 0. And I'm going to make k negative 2. G of x equals 1x minus 0 squared minus 2. That's going to move it down 2 units. Great job. Okay. Find g of x, where g of x is the translation 10 units left of f of x minus x squared. Okay, so this is the one where we want to be a little careful. So a stays the same, 1. X minus h. So x minus h, it's going to move 10 units left. So 10 units to the left is negative 10, but it's minus negative 10. Okay, so x minus negative 10 is x plus 10 squared, and then k is just going to be 0. So what I want to point out here is that this is a little counterintuitive. The k part is intuitive because usually you think of a positive number as going up and a negative number as going down. With the h, you'd think of a negative number as going left and a positive number as going right. But because this is a minus here, at the end of the day, when you're doing x plus something, that means you're moving the function to the left. X plus 10 squared is going to move your parabola 10 units to the left. Subtracting 10, doing x minus 10, is going to move it 10 units to the right. Okay? So that's the one that you have to be careful with. All right. Find g of x, where g of x is the reflection across the x-axis. So a reflection is going to change a, like we saw earlier. So a is going to be negative 1 times x minus 0 squared plus 0. All the rest stays the same. Okay, translation 3 units left and 7 units down. So a stays the same, 1. X, so 3 units left. Now remember we said adding is left. So x plus 3 squared. And then 7 units down is minus 7. Alright, we're doing pretty well here. Let's do one more. Find g of x, where g of x is the translation 8 units right and 9 units up. So a stays the same. A is 1 times x minus 8 squared. Right? It's moving right, so that's a minus 8. Remember, it's counterintuitive. Plus 9. 9 units up is 9. All right. So feel free to rewind and pause or look at that video again, and hopefully that was helpful.